All right, gentlemen, we are on lesson 7.4, which is the solving of polynomial equations in factored form. Much of this is going to be rather straightforward, and I don't want you guys to gloss over this like this is something that is super duper easy, because typically what happens with these is that we come back to this and I've seen in math instruction, and rather than doubling back, we're going to express what our actual issue is here. I want you guys to consider what it means to be the solution for something. Here, I have a linear equation here. Here, we see that we have a slope of 2, right? Excuse me, we have a y-intercept of 2, and we have a slope of -2, right? Down 2 and then right 1. So in the slope-intercept form, this guy's going to be y equal to -2x plus 2. Now, here's what we want to know. We start actually talking about the terms roots and solutions and zeros of these functions. Now, here's what we're talking about. What we're wanting to know is this. What we're looking for is where we have the whatever curve or whatever graph we have crossing the x-axis. When we have something crossing the x-axis, you guys can see that on the x-axis, the y-coordinate is equal to 0. So in other words, we're looking for a 0 of a function. And remember that in a function, which is f of x, that's the same thing we've effectively figured out. It's effectively the same thing as y. In other words, we're trying to figure out when this f of x is equal to 0, excuse me, or that y itself is equal to 0. So in other words, it's this, where we have 0 equal to -2x plus 2, right? If we were to solve there, we're going to find that x was ultimately 1, which makes sense. It should make sense. Why? Because go back here, look at that. That's exactly what we have there at the intercept for the x-axis. Now, some of you guys are thinking, we've been doing stuff with the second-degree polynomials, and we're going to do more with that. So I want you to understand what's going to happen here. We're going to have multiple roots here. And I want to show you how we're going to solve some of these more simple roots. So what you're going to see here is we're going to solve each of these equations. Okay? This is going to be rather straightforward. You'll see the following. 3x times the quantity x minus 6, and that's going to be equal to 0. Now, typically when you guys see this, you're thinking, oh, let's start distributing and let's get crazy. That's not what we're going to do here, okay? What we want is prior to distribution, if we actually were to, in the case sometimes that when we have it not just a monomial times a binomial, but we'll have binomial times binomial, right? And the multiplication of that creating a trinomial, we're going to start to undo that, all right? And we're going to factor that. So we've gone through the exercise of actually multiplying and using the FOIL method, but moreover, what we're going to have here is we're going to have a split. We have two separate problems. We have 3x being equal to 0, and we have x minus 6 being equal to 0. They're separated, of course, by the notion that these two separate, one monomial, one binomial, are being multiplied times each other. Okay? So it's effectively, this is what's known as really like the zero product property. When we solve this guy, solve for x, x is going to be equal to 0. When we solve this guy, x is going to be equal to 6. Gentlemen, that's your answer. I don't need to really, I mean, if you go through this process, right, divide by 3, or add 6, I'm fine with that. But that's not something that's in the default of what I need you to do in order to solve this. The bigger thing is that you get the concept that you have two different equations that you are solving here. Let's actually do another one. We have x plus 5 quantity times the quantity x plus 4 equal to 0. So again, gentlemen, I have two problems I need to separate. I have x plus 5 equal to 0, and I have x plus 4 equal to 0. When I solve each of these, I'm going to get two solutions. One is that x is equal to -5, and the other one is that x is equal to -4. Those are your solutions. okay? Let's keep going. Sometimes we're going to have what's called a repeated root, okay? I'm going to show you guys an example of that. And we don't always have to use x, right? Let's just use a different thing. Like let's do c plus 5 squared is equal to 0. So this is going to have a repeated root. In other words, we have the same answer happening here, and I'll show you later why that happens in the graph of what this guy makes. But x plus 5, or c plus 5, effectively we have is c plus 5 equals 0, right? Because what we have here is the following. This is really c plus 5 times c plus 5, okay? Now, we had the whole, this is a binomial square, which we just worked on in the last lesson. And of course, we have a method to have the outcome of that binomial multiplication. But let's remember what exactly this means. So we have c plus 5 equal to 0 and c plus 5 equal to 0. But why would we do this problem twice? I mean, it's going to have the same, not c, and not x, it's c. It's going to have the same result. It doesn't mean that there's two answers, right? All we have is this one, and it means that it's a repeated root. Okay? And here's the issue. Typically when we see this is what we're looking for. When we have a second degree polynomial, right? When you have a second degree polynomial, we're going to have the anticipation that we're going to have two roots, right? And we technically do, but one of the two roots are going to be the same. When that happens, it means the root has been repeated, okay? And that's okay. That's going to happen, actually not just with second degree polynomials. It'll happen with higher degree polynomials. Let's do one that looks like a difference of two squares. This guy. 4x plus 5 times 4x plus 5. This guy's equal to 0, okay? I'm sorry, 4x plus 5 and 4x, I said difference of two squares, right? 4x minus 5. Go ahead and make that correction. I again have two problems here. I have 4x, oops, use blue. 4x plus 5 equal to 0, and I have 4x minus 5 equal to 0. Minus 5 minus 5, I have 4x equal to negative 5, right? Solve for x. X is going to be equal to negative 5 over 4. Add 5 to both sides. I have 4x equal to 5, so x is going to be equal to 5 over 4. These are my two roots, right? Nothing repeated, just my two roots. You can have more than just the two roots. Like, we could multiply this whole thing out if we really wanted to. We didn't go through this in the last lesson. But we actually could do this thing. Now, what we would do if we were going to multiply it out and we weren't solving for the root of a, and figuring out what its zeros are, right? So you'll see this, the 0 of the function, right? This means that you just make the thing equal to 0 and you want the solution for what the variable is. In other words, you just solve the problem. Right? People get too creeped out by that word or that term 0 of the function. What we could do, by the way, if we were interested in the multiplication of this, is that we could just separate this out, go binomial times binomial, FOIL, right? Get the result of the trinomial, and then we actually did the multiplication of a trinomial times a binomial, and you would do that, and you would have the result being a third degree polynomial, and actually we'd have 4 terms. I'm not going to do that right now because that's not what this exercise is about. If we had actually started with that, we can back our way into getting this, to get a solution and getting zeros of that particular function. So I have 3 different problems I have to set up here. Right? So a minus plus 5 equals 0, a minus 2 equals 0, and a minus 7 equals to 0. So a being equal to negative 5, a being equal to 2, and a being equal to 7. So those are my 3 solutions there. Okay? Let's factor. Okay? We haven't gotten to hardcore factoring yet. Let's factor a rather basic one of these. Okay? Let's do this guy. We're going to solve 4x squared plus 12x equal to 0. Now, in order to do that, I need to factor, okay? Which means I'm going to look at each of these terms and see what could come out of each of one of these. Well, first, and you'll hear me utilize this same mantra as you may have before. First, we deal with the numbers, then we deal with the letters, okay? So, first, the coefficients, 4 and 12, okay? What can be factored out of the two of those? And the answer is 4. If I factored a 4 out of 4x squared, okay, I'm left with x squared. And if I factored a 4 out of this, right, I'm left with 3x. But not only can I factor a 4 out, look at the variables. What can I factor out of x squared and x? And the answer is an x. Now watch. If I pull a 4x out of 4x squared, I get left with x. And if I pull a 4x out of 12x, I'm left with 3. If you don't believe me, multiply it back. 4x times x is 4x squared. 4x times 3 is 12x. Same thing we just started with. The whole thing is equal to 0, right? And we just did this problem. It's actually two different problems. 4x is equal to 0 and x plus 3 is equal to 0, meaning that x is going to be equal to 0 and x is going to be equal to negative 3. And those are your solutions. Okay. Next, let's solve. Let's make it a little bit trickier. Negative 10a squared equal to 8a. Well, let's move everything over and make the whole thing equal to 0, right? Okay, so if I do that, let's subtract 8 from both sides, 8a from both sides, right? So what I'm left with is negative 10a squared minus 8a, and that whole thing is equal to 0. Let's make my a little bit better. So, what can be factored out of both of these terms? The whole thing's still equal to 0. Well, what can I take out of both negative 10a squared and negative 8a squared? I can factor out a negative 2, right? And an a. If I factor out a negative 2a from negative 10a squared, I'm left with 5a. If I factor out a negative 2a from negative 8a, I'm left with positive 4. If you don't believe me, multiply it back. Okay? Negative 2a is equal to 0. 5a plus 4 is equal to 0, right? So a is equal to 0 when I divide there. And a, sometimes I need to do a little extra work here just to make sure I'm doing this right, especially when it's going to involve a fraction, right? So a is going to be equal to negative 4/5. So those are my two solutions. All right, that's what I've got for you for today. Oh, you know what? I've got one more. I'm going to solve the following problem. Negative 5/16 times x plus 8 times x minus 8. All this is equal to 0. Now, here's the trick. There's a big difference. Gentlemen, we were dealing with this problem back up here. Let's go back. Here, this guy. Right? I had monomial times binomial, 4x times x plus 3. When I have 4x times x plus 3, I have 4x equal to 0 and x plus 3 equal to 0. Okay? But I can do that because each of these has a variable that I can set equal to 0. Okay? That's irrelevant here. I can't make this guy equal to 0. So here's a trick that I have that I can get rid of that fraction because he's just kind of hanging on and complicating this problem. I can multiply both sides, right, by negative 16 over 5, right, to factor all of this out and effectively just get a 1. So now I have x plus 8 times x minus 8. Remember, you can do this algebraically as long as you do it to both sides. If I do it to both sides, it's still going to be an equation. It's still equal, right? So as long as I apply the same inverse operation by multiplying times negative 16 fifths, On both sides, I'm okay. The best part about all of this is when you're finding the 0 of a function, if you multiply times anything times 0, it's gone, right? It cancels. So when you guys move forward on these problems, I'm going to do one more of these afterwards, right? And again, this is going to be a quick solution here. And I do need to show you guys to show me this step always on these problems, at the very least. Okay? And my two solutions of -8 and 8, I think some of you guys might be seeing a shortcut that you could take here, right? Think about this. As long as you don't have a variable right there, and you just have a coefficient, right? And I had 2 times x plus 3 times x minus 2 equal to 0. Can't I just cancel that off because I'm going to multiply by 1, divide by 2? Here's the thing. Even if I take this whole thing, I divide both sides by 2, right? That's going to factor out. What's 0 divided by 2? It's going to be 0 anyway. So in other words, you can just cancel off this 2. And I can go straight to x plus 3 equals 0 and x minus 2 equals 0, right? To get my solutions of -3 and 2. So there you go. That's it. Your assignment is posted to Canvas, and go ahead and get started. Good luck.